This video will talk about how you can prove a quadrilateral is a parallelogram. So the first way that we can prove a quadrilateral is a parallelogram is if both pairs of opposite sides are congruent, then it's a parallelogram. So in our figure here, we've got that AB is congruent to CD and AD is congruent to BC. So if both of those are true, then it means ABCD is a parallelogram. Turns out that if both pairs of opposite angles are congruent, it's also a parallelogram. Okay, so if both pairs of opposite angles are congruent, then it's a parallelogram. Okay, so we can use these properties to solve problems. If we look at our first example here, we want to find out, is this figure a parallelogram, and if so, how would I know? So I'm missing one angle, so I'll call that X. And I know that since it's a quadrilateral, the angles all have to add up to 360 degrees. So X plus 105 plus 75 plus 105 has to equal 360. So if I add up my numbers, they add up to 285. So X plus 285 equals 360. And I get that X is equal to 75. And so this is a parallelogram because both pairs of opposite angles are congruent. Look at the next one. On this one, my opposite sides, one set are 73 and the other set's 98. So both pairs of opposite sides are congruent, so that one is also a parallelogram. Okay, and a couple more properties. If one pair of opposite sides is both parallel and congruent, then it's a parallelogram. If one pair of opposite sides is both parallel and congruent, then it's a parallelogram. And if the diagonals bisect each other, it's a parallelogram. So essentially, this is just the converse of what we learned in the last section. So if we look at an example here, for what value of X is quadrilateral PQRS a parallelogram? Well, I know that diagonals would have to bisect each other in order for it to be a parallelogram. They've already marked one diagonal bisected, but that means that PT would have to be congruent to RT. And so that means that 5x would have to equal 2x plus 9. And so if we subtract 2x from both sides, we get 3x is equal to 9. And dividing by 3, x equals 3. So if x is equal to 3, then PQRS is a parallelogram. So just to recap, there's actually 5 tests to see if something is a parallelogram. First of all, the definition. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. One pair of sides is both parallel and congruent. And the diagonals bisect each other. So we've got one more example. If I'm given the coordinates for quadrilateral ABCD and I want to know whether or not it's a parallelogram. So point A is at -3, +3. Point B is at 2, 5. C is at 5, 2. And D is at 0, 0. So we can't just base it on what it looks like. We have to actually test and see whether the sides are parallel. So when we have lines, parallel lines, they have the same slope. So I need to look at the slope of AB and compare it to the slope of DC. So for AB, I'm going up 2 and over 5, so it equals 2/5. For DC, I'm also going up 2 and over 5, it's 2/5. So because they have the same slope, I know that AB is parallel to DC. Now I'll do the same thing for the slope of AD and BC. So for AD, we're going down 3 and over 3. So -3 over 3 is -1. And then for BC, I'm also going down 3 over 3. And that also equals -1. So AD is also parallel to BC. So that means that quadrilateral ABCD is a parallelogram. Because both pairs of opposite sides are parallel. And that concludes this video. Thank you.